So, something is going wrong. The thing that's going wrong, it's the number of applicants for computer science classes in universities. This is a global problem. And another problem is, from these students that are applying for the computer science classes, usually nowadays their skill level are lower than before. And this is a huge problem, mainly for us. When you talk about this, everybody say, okay, the solution is education, education, education. My proposition here, yes, education, but how? I think we have to hack education. My name is Rubens. I work at Second Quadrant. I'm a Postgres consultant and a system administrator as well. This is for the media if you want to tweet or something. And also, everything that we're going to see here, you use playbooks and you use Ansible playbooks and all the programs that are going to show to you. It's in that repository in GitHub, if you want to check. And this website is specifically for Postgres with Raspberry. The last post we did there was how to compile Postgres 9.6, I think, for Postgres. So it's a little not up to date because we are doing tests for Postgres 10 now. So we are going to put a new article there for Postgres 10. And if you want to put the hashtags on Twitter, you know. Just to make something clear, when you hear the word hack, is a kind of polemic because the media always say the hacker is always do something bad. Actually, being hacked is a good thing. And yeah. Being hacked is a good thing, and this is a good explanation that I found about what is the real meaning of hacking, is you find the pleasure to find solutions for problems. That is hacking. It's not anything, it's not anything bad, yeah. And no cracking, no. So being hacking is good, being a hacker is good. And this is general for the talk. And I'm going to go in some details about the problem that I said in the first slide. If you compare, in the 90s, usually the applicants for the classes, they were already hobbyists. So they start the classes, the university with a little, usually not a little, but they have experience already. During the 2010, I don't know if any of you here has experience teaching in some universities, the level of knowledge of the students were getting lower and lower and lower. A friend of mine that gives classes, he's a university teacher for physics in Brazil. He told me something really funny. They have usually the physics 101. Yeah, it's the first class when you go to the university to have, to start any class actually, but he was talking about physics. In the university he was giving classes. They have to do a pre-101 class to help the students to understand the 101. Because they didn't have the level to start at the 101 physics. This is really bad. And I don't like to talk about numbers without showing the data. So all the numbers that I'm going to see here is about the US, this is in the United States, the US market, but this is a reflex of the thing that is happening all around the world. If you want to check the numbers, I'm going to compare the job market. So the Bureau of Labor Statistics, they do statistics every year about the market situation. And about the students is the association, the Talbi survey. Every year they publish a new one. Based on these numbers, this is an interesting one. You can see here is the number of bachelors, laurea, from universities in the United States from 95. You can see that you get a little higher here, a lot higher actually. So this is the number, 20,000 new guys being, new students being graduated per year. And in 2005, 2004, it starts to get down, and this is the problem that we start having. For a coincidence, the lower point was in 2009. In 2009 was when the Raspberry Foundation was founded. We are going to get in details about that. And right now, it's getting higher, it's getting back on track. Of course, not because of Raspberry. This here, when something like that happens, has a lot of reasons. It's not one reason only, it's a lot of things. But the same thing when it starts getting back on track, it's not only because of one thing, it's a flux of a lot of things. But actually is a coincidence. And this here is the market, oh, it's cutting. This here is the market situation about STEAM. It's the area that we work. So it's science, technology, engineer, and mathematics. This part here is specifically for computer, is for us. This is the expectations for the next 10 years, the number of places on the market that we have for workers. So new places on the market. It's bad that we're not going to see it's cutting down there. We have this thing compared with the other graphic. It was comparing the number of students or graduates that are going in the market and the number of jobs that are open. So we will have less students being graduated than the number of opening places on work market. So we always have less. We always have positions open that's not full, not filled by the number of students. If you this is okay. This is the explanation of all the things I'm saying. This graph is comparing the number of students with the number of jobs. So you can see for all the STEAM areas, so you have engineer, mathematics, all the technology jobs, the number of jobs that are expected, and the number of graduates that are going into the market. So, and this is a projection, of course, until 2022. I think everybody here has some problem in your company to find new guys to work. And usually it's complicated, you have to give trainings when the guy goes there, but it actually is a really big problem. And this is a problem that is affecting all of us. This is really bad, if you think about it. One of the reasons, of course, again, is not one reason only, but one of the reasons is that the schools, they are training the students, the teenagers, because that is the most important part of your educational background. They are teaching the students to be consumers and not to produce, to make technology. And that from the Microsoft Office is funny because I know and I see this happening, probably you know. I know a college, high school in Brazil and United States as well. They were supposed to be a technical high school and they were giving classes for computer science to the students in the high school to learn Office. For real. So if you learn, not against, I don't have anything against Microsoft or Office or whatever, but if you learn how to use Office, you're not learning how to make technology, you're learning how to use technology. This comparing to the other generation before, I don't know if any of you had the chance to play with the Commodore or with the Spectrum, all the other computers. It's a difference in generation. You didn't have, you are not afraid of breaking anything. You're always trying to have fun and making games. You don't think that you are learning, but you are learning in the process. So when you go to the university, you know a lot already. This is not happening anymore. Because, where is the computer there? Yeah, actually, you need a time to see the computer. Because the computer becomes a furniture. You are afraid of taking this. Actually, you cannot open this one. Is everything glued? You cannot change anything. And this makes you to be afraid. You just use that thing. It works like it is. You don't have to change anything. And this changes your mindset. The goal is learning. Doesn't matter how. You have to learn. If you want to break your computer, break it. Of course, I'm not going to break, but we are afraid of breaking. And this is blocking us of learning. And learning is supposed to be fun. Everybody forget this. I like these two quotes about that Benjamin Franklin and Richard Feynman, they said. I believe in this. You have to have fun when you learn. If you don't have fun, you don't learn anything. Learning is supposed to be fun. And this comes the Raspberry Foundation. I don't work on Raspberry Foundation, just to make this clear. I just think the thing that they found, that they did, was nice, and start a new wave of, you have a lot of these computers today, like the mining computers, not only Raspberry. So the Raspberry Foundation was created in 2009, is a charitable organization, and was made on Cambridge in England. And the goal was this, was to promote the study of computer science and related topics specifically to school level. Because it's the time that you're not afraid of breaking anything, you are curious about the things. When you go to the university, it's late already. Of course, you can learn in the university, but it's better if you arrive there knowing stuff already. And the idea, the goal is to have a computer that was fun, programmable, affordable. Maximum, the goal was $25. One problem that had with the Commodore and the Spectrum, I don't know if any of here had buy one. I don't know how much it costed here in Europe. In Brazil, was really freaking expensive. I could not buy it. So I always reading magazines and trying to buy that, but it was too expensive. This, $25, you can buy it. And being robust, you can do it. Throw this through the window, it's not going to break. And they make the Raspberry Pi. And they reach the goal. It's already open. If you want to close, you can close, but you don't need it. It doesn't have any specific function. You can do a lot of things with it. Like this project I did, you can do many things. You can give any use that you want. And in the end, it brings back curiosity, joy of thinking, and fun of learning. This starts a kind of movement. And I put kids' pictures there. But actually, today is funny, because every time I take this cluster, I go 2 places that people make more questions. This is when in conference with adults, everyone, oh my gosh, what is this? Or with kids. Teenagers, they don't care too much. But kids, they want to mix and do everything. You can build a lot of things. I'm going to talk about some of these projects. Everybody buys a Raspberry trying to do a media center in the television. Works nice. And, okay, let's see each one of them. This one is the Astro Pi. Actually, this is a titanium box. They did, I think NASA did this. And this is orbiting Earth and keeps sending signals. You can see when it's up your city. It's a really nice project. This one is really good as well. They downloaded all the Wikipedia and another knowledge bases, put in the Raspberry. This Raspberry is the server in the class. So they put this in the schools. They don't have internet in the schools. So they create all of these computers. They have Raspberries as well. So the more expensive thing here is the monitor. They put the Raspberries in the server, and they have access to all the knowledge that you have in the internet without internet. This is really nice. This Rachel Pi is a really nice project. This one, you can make a drone and control the drone by a Raspberry. The Raspberry is here. And because the Raspberry has this GPIO, so you can control other stuff. And because of the community, you can find all the projects on the internet as well. I was thinking about making a drone to bring here and make, but I didn't buy the drone yet, so when I do. This one is specifically to us. It's a really interesting project that a company that has a huge database that's not Postgres did. I'm not going to say who is. Oracle. So they did a weather station. They make a weather station, put this box in all the schools, in the high schools in the United States, to measure climate change and measure the weather. Everything is related and put in a database. That's not Postgres. But this is, actually they are really smart because nobody knows what a database is. So if you teach kids in the school what's a database, and the database is Oracle, they're going to get, learn that thing. We are supposed to do something like that. Please help me. Yeah. Another part of the Raspberry that is really nice is the community. The community is really huge. This is one of the biggest part of the Raspberry. You can find any project that you want to do with the community. People are friendly, help you to do anything. And because of the community, they made different boards. We call these hats because you can put them on the top of the Raspberry. So it's a hardware attached on the top. You can find hats for everything. This one here, which one? This one is a sensor board. So you can measure humidity, pressure, can measure a lot of things. And they're not expensive. And you can have also monitors to plug in the GPIO here. They're really nice. And it became actually pop. I don't know if anyone watches Mr. Robot. He invaded a company with using a Raspberry. Yeah. And it's becoming, you have a lot of magazines, and it's being used in a lot of different places. Poor schools, rich schools, schools in a really faraway countries. It's nice. In March, they sold 12 million units. But as it's not a shareable, it's a shareable foundation, it's not thinking about gaining money. Sometimes they take this money and put back on education. So I think this was in 2014. They put back £1 million and to make projects and to put in education. They keep doing that. And of course, again, Raspberry, it doesn't, oh my God, okay. Doesn't say that's going to fix all the issues in education. This is a completely different discussion, but it tries to help. Okay, now the Raspberry. Everybody's expecting. The Raspberry, you can install anything, even they say Windows, I haven't tried yet, but usually Linux. And you can put BSD as well. For that, yeah? Yeah. No. Thank you. No. Okay. Usually you are going to find a Raspbian. This is a Linux distribution based on Debian. And Arch Linux as well has a really good distribution to install on ARM. The installation is really easy. You just download the zip and this compact and put in the SSD card. Today there is an application, I think is Etcher. I don't remember the name of the application. It does everything automatically. You can use DD, it's going to work fine. Just go to the documentation, everything is explained there. No, not problem. You have installers for all the operational systems. The configuration, the last one, it configures everything automatically. And there is a GUI app actually to configure, but you can do raspi config, and it's going to configure there. The hardware. We have the 3 different Raspberries here. You can see the main difference. The price is still almost the same. And you have 3 years between the 1 and 2, and 1 year between 2 and 1. Mostly is the CPU. This is a single core. These 2 are quad cores. The memory changed a lot as well, not from 2 to 3. The biggest change for this was Raspberry 1 to Raspberry 2. We are talking about this before starting the talk. If you are going to buy something today, you don't have any reason to buy a Raspberry 2. It's the same price, practically. Because we have a lot of different versions of Raspberry, it's better if you check the PCB revision to be really sure about what is the characteristics of the Raspberry. You can check everything on this website. If you cannot see here, I'm going to put this slide later for you to check. Benchmarking. We did the benchmark on Raspberry, the same benchmark that we do for clients, for servers. We want to see how it's going to work with Postgres. The benchmark, Jonathan Battiato, he is going to give a talk, is later I think. He's going to give a talk about benchmark. If you want to check, it's really interesting. I'm not going to get into the details of how the benchmark works, but seeing the numbers is nice. So we check the disk speed, file system, read and write rate, and stream scaling. So the speed from the CPU to talk with the memory. And then later we do a Postgres benchmark. First trying a database that's just on memory, and then a database is written on disk. So pi versus pi, again, the main characteristics. This here was really updated, so we have Raspberry 9. The point here to pay attention is the storage. This is really important. We use the same storage, actually the same disk. I took the disk from one and put in another to make sure that the disk is exactly the same. If you want to buy an SD card, you have to be careful because sometimes the same brand and the same model, they have different performance. So it's better if you test. And it makes a huge difference. So here, we did the ZCAV, the ZCAV, and the CPU, the stream scaling, the CPU talking with the RAM. I don't know if any of you have done the ZCAV. The ZCAV is the zone, it checks zones in the disk. Usually it's used for a rotational disk. So you can see in a rotational disk, you are going to have a down. It's not going to be a line like that. You are going to get a down usually, because it reads and writes faster, closer to the center of the disk than outside. So it's a zone check. As this is a SSD, you don't have zones there. So it starts with the same speed and goes all the way. This is the way you have a benchmark with SSDs. And this was supposed to be 32 megabytes per second, I think. We reached almost 20. Is good enough. For the CPU stream scaling, now you can see the difference. This is a single core, Raspberry 1, so Raspberry 1. It's a single core, so it starts at the top and doesn't have any other core, so it just goes down the speed of talking from the CPU to the memory. Here is a quad core, so you have 1 to 4 cores. And here you can see that it goes up, talking, because you have more streams to talk with the CPU. Here for the Raspberry 3, from this one to here, the improvement's amazing. From this here is 1.8 terabytes per second. Here is 2.3 terabytes per second. It's better, it's not that huge, but it's better. File system performance, one information for you guys. Everybody asks, oh, it's better than X4 or XFS? Usually the performance is almost the same. And here again is the same number that you have for the reading for the SSD, 25. But you can see they are almost the same. Because it's the same disk, it's going to be the same result. For the Postgres performance, I don't believe. Sorry. Okay. We do the tests. This is the test in memory, this one, and this is on disk. The number of transactions that we have, this is the TPS, transactions per second. You can see from the Raspberry 1 to the Raspberry 3 is a huge difference. These are nice numbers, but you have to have in mind that this is a small computer. But this number for a small computer like that, they're really nice. And on disk as well, you have an improvement from Raspberry 2 to Raspberry 3, but the biggest difference from 1 to 2. This is the data of the size of the database we created. But if you have the number for the benchmark and you cannot compare with anything, these numbers, they don't say anything. So we compare the Raspberry with some server from clients that we had done before. So it's a Davi versus Goliath. The Raspberry 3 with a server, I'm not going to say the brand of the server, but the octa-core is a nice server. The only thing here is this storage. This is a, how do you say, a ovo kinder storage. This client, he bought this server, but he didn't have any storage, and he said, okay, please do a benchmark with this. We told him, okay, the benchmark is not going to be real because the storage is not a real server storage. He said, whatever, just do for me to know. I said, okay, let's do it. So keep in mind, this is not a production storage. There's the disclaimer, okay? So now we can see this here, Raspberry 3. This, which one? Yeah, this is the Raspberry, this is the server. This here, you can see the ZCAV is a rotational disk, so it starts and goes down because this is rotational. The Raspberry you cannot see there, but it's the same one as before. And this goes to 108 megabytes per second. It's not that fast comparing to the Raspberry. The stream scaling is a lot faster because this is the CPU, so it goes up. The file system, here I go to 250 megabytes per second, then comparing to the, it's 10 times faster regarding the file system. But here is the interesting part. We go to the Postgres benchmark, and you can see the Raspberry is faster than the server. So you can put a Raspberry in the production. Why this happen? This here is the storage. Because if you think about this benchmark here, actually is a test, is a benchmark between an SSD and a rotational disk. It's not between a Raspberry and a server. So please don't think you're going to put this Raspberry in your production. It doesn't work like that. This tells a lot of things. SSDs are faster, and if you buy a server, please put a good disk there. When we change the disk, but yeah, the walls go on disk. Yeah. The database is a good question. The database is on memory, but it has to write the walls on disk, so it has to access disk anyways. Then when they put a disk there, a real disk, the numbers changed. Okay, so you cannot compare their oranges and apples. The Raspberry is a good computer. I know some people, they use Raspberry in production in some stores for a specific use. They need for that specific use. It's the same thing if I need something for the Raspberry and I put a server like that. It's stupid. I don't have to do that. I need a Raspberry. But the opposite is true. If I need a server, I cannot put a Raspberry there. And this here is comparing the number when you use, this is that server initial with the disk, a real disk. This one, we had the chance to do a benchmark in IBM Power 8. So I want to put the numbers here just to compare. This is a good server. This is a, yeah. So the numbers are a lot better. But if you think about it, the Raspberry is okay. You know, yeah, it's nice. Yeah, if you compare the cost, yes. So just talking about Postgres, the idea for Postgres, the project that we have in mind was to use Postgres focused on education. Because Raspberry, the idea, as we saw there, the goal of the Raspberry was to be used in education. So we tried to make people understand what is a database and what's Postgres and what's open source. So we did this project. Embrace the educational potential of Raspberry using Postgres. To avoid this kind of questions, I think all of you, you heard, oh, I have a nice application. Do I really need to use a database? Yeah, you need but use wherever you want. To avoid this thing, people don't understand what a database is and what difference it makes. Getting back to the graphs that we saw at the beginning, this part here, is just the jobs for database, related to database in the market. So we are still a small percent in that huge system. So I'm trying to, if you do this, maybe you're going to get to be better known. So we did the PG bramble. A bramble, it's a word in English that I didn't know before, is this thing when you have like fruits, like berries. Yeah, you have a bramble. So you can see the resemblance. Why build? The idea that when we did that was to learn Postgres and to have database server on classrooms. But you can do a lot of things. You can do this for testing. You can test PostgreSQL, PG logical, stream application, just to test. You can put everything there. Put like 100 Raspberries and put PostgreSQL to see how it's going to work. You can also put use this as a dedicated server in your house and helps organizing the mess. Specifications of the project. There we have Postgres master. in that cluster there. So there is a master standby with stream application, a barman server doing the backups, and in our disaster recovery, and this is working. If some of you guys saw the Gabriele Bartolini talk, that is the same slide that he arrived in the end. We have the same thing there. And we have some clients that have the same organization there. Of course, that is a small... Someone said to me that was a proof of concept. Yeah, you can see like that. And we are putting automation as well, so everything is automated through Ansible. When we built that, was everything with Raspberry 2. The numbers don't change that much, but everything that we have there, everything with the hub, everything, you can make like 300 pounds with 4 computers. It's not expensive, if you think about it. And including the case as well, it's everything. The technology involved, you have Postgres, Linux, Barman, and Ansible to automate. And there, the idea is to have an application server. You can use the application you want. In the case here, we are putting Nginx. And this is the diagram. So you have the master talking with the standby. Everything goes to Barman, and the standby can get parallel wall from Barman, and here you have your application. So, and it works. Postgres on Raspberry, how do you install? The last, as I said, the Raspbian is based on Debian. The last one is Stretch. When I saw this a week ago, they have just Postgres 9.6, and that's something that I tried to do. PGDay.IT, Postgres, doesn't have an ARM repository yet. Marco? Yeah. We are trying to fix that. So the thing is, you have to rely on the distribution, on the Debian repository. So today you just have 9.6. But if you want, in the installation, after we install there, that's a normal computer. So to install Postgres is like any other Linux. It doesn't have to do anything differently. If you want to install Postgres 10, you can, of course, compile it. On that blog that I linked in the beginning, when I did the blog, there was just Postgres 9.4. So we did, I don't remember if we did how to explain how to compile 9.5 or 9.6, I don't remember. But if you follow the instructions, it's really easy. And actually you learn how to compile Postgres. And on the Raspberry 1, it took around 4 hours to compile. Raspberry 2, 2 hours. It's not... Configuration is the same with PostgreSQL. And automation, everything is automated with Ansible. So if you go to the GitHub, you have all the playbooks there. I have to update something, but it's supposed to be working. If it doesn't work, please send me an email. I can try to fix it. Conclusions. Raspberry is on school. We can put Postgres there together. And please, if you like this, do your project, divulgue your project to the community, and share the results. Have fun, always have fun. Grazie a tutti. Okay. I was thinking about doing a demo, but we are short on time. I don't know if you have a question. Oh, sorry. Yeah. Anyone has questions? I think it's off. Oh.
Do you know something about problems with HDMI port or power with Raspberry 2 and 3?
Not that I heard of, but okay, making a...
If you know something.
Today, we have a lot of different boards like this one. And some of them... there's another question there, I think. And some of them today, they are actually, in hardware-wise, they are a lot better than the Raspberry. So it's like I said, I don't work for the Raspberry Foundation. When I start working with this, to try to do these projects, this was the best hardware that was out. Today you have a lot of better ones. For example, one critique that I have about the Raspberry, you don't have a SATA on the Raspberry. So you have to rely on the SSD. Some other boards, you can put actually a storage, a SATA storage connected to the Raspberry. It's not the Raspberry, but the other one. But you have to have in mind the community and the price as well. So if you care about the community, I'm going to say, okay, go with the Raspberry. If you want the best hardware, you don't care about if you're going to spend a little more, like instead of 35, go to 100. Yeah, I would not buy a Raspberry if you think only about hardware. But you have to, you have to think about what you want.
So I have quite crazy question. There's PG Storm for the GPU usage on Postgres. There's GPU on Raspberry. Have you ever thought about mentioning it? Or does anybody thinking about this?
I haven't heard anything yet, because the thing is we don't have a specific part of Postgres working with ARM yet. So yeah, we can start doing something.
This is CUDA, so probably there's no CUDA for the GPU.
No, I haven't. But there is a lot of things. For example, there are some people that are doing projects with Docker now, with Raspberry, installing Docker on Raspberry. If you try to research, I haven't heard about. But probably there is. You have to research or start one, Other questions? Okay. Thank you very much. That's it.